suppose we start anyway.
Yes, let's start recording and.
Good.
Multiple sites were never part of IFC. I mean, one site was never part of IFC. That was just an implementer agreement in 2x3. I think it was after a couple of years they agreed that a couple of implementers agreed that it's one site, but this was never an IFC. It was just an implementer agreement.
In IFC or in ISO?
In IFC. I mean, in the IFC specification. When I say IFC, I mean IFC specification.
So what would you suggest then? Because I will instruct the developers to fix this so we can have several IFC sites.
I think that's a good idea, yes.
Yeah. But should we allow that from 2x3 or should we just allow this from IFC4 or?
Well, probably from IFC4 onwards, because in IFC4, I haven't seen this in the documentation anywhere, so I guess they dropped it from their discussions after 2x3. I'm certain in 2x3, Stefan, you have the link for that implementer agreement, maybe, because
I'm searching. Yeah.
Yeah, there was this implementer agreement, but it was never taken over to the specification, so it was never in general usage. So meaning when there were technologies to encode such rules, they never took it over. So I would assume they dropped it in the process from 2x3 to 4.
Okay. So if you allow this from IFC4 and outwards, that should be okay in our software.
I think so, yes.
Very good.
But this would probably also be a good question to raise at the General Assembly of Implementers, where stuff like this was usually discussed in the past. And I found the link. So this is the Implementers Agreement 141. It only affects coordination view or extended coordination view. So its scope is clear, and that is only 2x3, and it is either no instance or exactly one instance of IFC site.
And where can that be found? I mean, these agreements, where is it, if not in the specification, where do you find it?
It's always here in the, I'll post it in the chat. It's basically publicly on a web page from Building Smart. You have all these agreements, and most of them apply to 2x3, I say.
So does that mean there'll be a totally new set of agreements, or 4x3, so we can go through all the 2x3 ones and throw out the ones that are meaningless for us?
There shouldn't be any implementer agreements after IFC4 because they are all encoded in general usage. That's general usage.
Yep.
Those agreements.
Thanks.
But I don't know what they want to do for 4x3 because apparently they again want to have some sort of a mechanism for implementer agreements. Although they now have concept templates and general usage in the ISO. So you have a sort of a paradox there where you have certain agreements that Evandro proposes that go against what's accepted by ISO, which is a bit problematic in my view, at least.
It's not yet clear, yes, what 4x3 will be. And as you see, there are only 6 agreements on the version IC4 of which 2 are in progress since 2014. So, you know, all of this has been, let's say, moved to the ISO specification itself, because 2x3 did not have that part of specification yet at that time. So
okay, so
does that sort of answer your question, Jan Erik?
It does, but this was just the first of 2 questions.
So that's is it allows relevant to have more than one IFC site, right?
All this is answered now, but I have another question in the issue list there.
Which
about
is
the voxels.
Yeah, let's look at this one as well. So yeah, Lars, Sergey, Michelle, and myself had a very productive meeting 2 days ago, and we went through most of this, let's say, also strategic issues. So yeah, for the voxels, you have this. It's split in 2 parts, right? You have the voxel grid, which is the geometric representation, and you have the voxel data, which is the semantic representation. So the voxel grid was we have already proposed expansion on the concept templates, I believe, and expanded the necessary functions in the express schema. So voxel grid or geometric representation is already merged in the specification. The documentation needs to be regenerated, and we are planning to do so before we start with Sprint 3 mid of next month. And for the voxel data, we are still, let's say, finalizing the details. So you can see some examples. And I think your question then was how to get the description of the parameters. Sergey, can you perhaps point me quickly to where can I see that?
What are you looking for?
Description of the parameters of IFC voxel grid.
It's the I try to mark them as bold. These attributes 3805.0 etc. What
These
are
ones,
these?
right?
Yeah, yeah, exactly.
Did we not document them all? It could be.
It could be that their documentation is only in the specification, but not in the documentation repository. I'm not sure. I'm looking through the specification repository.
At least that was what you said. So maybe I haven't looked carefully enough in the documentation.
Yeah,
Voxel grid seems to have the documentation for all of them. Which ones would be missing?
Oh, yeah. It does seem that they are there. So it's not the correct link. There's the correct link. So voxel grid. Let me zoom in a bit. First attribute is voxel size X, second voxel size Y, third voxel size Z. Then you have the number of voxel in all of 3 directions. And then you have the voxels itself. Just as I see this, perhaps you should do this non-negative integers or positive integers, at least one. Just a proposal to Sergey right away.
Oh, what's the proposal?
To not have IFC integer, but to have IFC positive integers. Be more specific here for the attributes 4 through 6. So this is the link I'm going to post in the, oh yeah, it's already in the chat. I'm going to post this also in the GitHub.
Very good. Thank you.
So how is the voxel positioned? Is it like the left-hand corner at the bottom or the...
That is a very good question. Nothing is written in the documentation itself, so
you closed entity definition.
And the other things that apply to it, like if it's rotated and stuff like that.
So the grid, the voxel grid itself is a representation item similar to also how other items work. So you can assign it as a representation, and then you have the object placement to place it in space, right? You can use any placement as you wish. But the good question here is this the left bottom point of the voxel grid?
Right? Yeah, the 0, 0,
what's
0.
What's the 0, 0?
Yeah.
Yes. I would assume it's the left bottom.
Don't assume. You have attribute 7 where it says that you're taking positive X, Y, and Z. I can make it more explicit that it's the local placement, but this, I think it should be quite obvious in which context you are.
I would prefer to make it even more explicit, yes.
And why the question mark on cardinality?
Because it's optional.
It's optional. Okay, thanks.
That's why it also says if not given, then you take whatever the voxel size X is. So, you know, if you have an equal amount of voxels in directions, you can leave out the other numbers. Which is probably almost never going to be the case, but, you know, technically speaking, it is still a possibility.
How do you then apply attributes to these things? I imagine these guys have attributes for every different cell and a color, and
that's where you don't. I mean, the voxel grid is only the geometry. Then you have the voxel data is where you have the data.
So a separate thing
in a similar way as, for example, you have the alignment horizontal.
It's by index.
Yeah.
Yep. Yeah, it's by index. So into that.
Yeah.
Into that array. Yep.
And that latter part we cover in the sprint 3 geo.
Yes.
And we have to merge one pull request before that.
Great. That are the questions from Jan Erik. Any other questions from the group? Or Jan Erik, if you have any additional as well, of course.
Of course, I always have one more question. I tried to look. I got a pull request link from Lars leading to the test file he has produced, but I couldn't find it among the files in the GitHub repositories. Is that some finger trouble from my side, or?
That's expected. Yes, you will not be able to find the file itself among the files as long as this pull request is not merged, but you can get the file itself from files changed here. So in its pull request that he's linking, there's a files change tab where, yeah, okay, this is a too big of a file. So you need to view raw because it's too long, but here you can get the full file. So at some point somewhere, yeah, there's quite a grid.
Yeah, it is. And it was possible to download also, so it was okay. But I wondered why it wasn't, the pull request wasn't accepted and the file in.
It's still on Sergey and myself to review the pull request.
Okay.
And when we do it, it's going to be among the files.
And that is maybe the case from the last sprint as well?
Correct.
Yeah. Okay. Because it's very nice to have these example files, of course.
Yes, we agree. It's just we still have a discussion regarding what was it, Sergey? The alignment parameter values and length measures that we're having that we want to. So there's the discussion between the three of us, Lars, Sergey, and myself, that we're not yet completely sure. And we want to, when we merge the file, we want to be sure that the file is really cool, really good, or let's say perfect, for you to have a really good reference.
Yep. Yeah, because it's extremely useful, these example files, I would say. So maybe a little bit cheating, but that's what work is all about, isn't it? So
that's why we also provide them. That's why we provide them, for you to have a look at them, to have a good guidance.
Very good.
So yeah, those are these two pull requests that we. The problem is not with the voxel grid, I believe. So voxel grid, voxel the representation, you can already have a look at and copy if you want. But the alignment is still something that we're trying to resolve.
Should we maybe ask Hanu or Nadia, Adam, whether you have any particular questions?
Yes, I'd like to
Please.
ask one question. I think it was on the last kickoff meeting that access to placement linear was mentioned, and I had a question that what happens if the ref direction is omitted? And I also had a discussion with Sergey by email.
Sorry about that.
Yeah, the point
I
by
was
distance.
traveling yesterday.
Okay, no worries. The point by distance expression, you said, Sergey, that it has to reference the distance along has to be calculated on the 2D composite curve of the gradient curve.
Yeah,
right?
let me guide you through the documentation on that.
Okay. And my question is also, if ref direction is omitted, if it also has to be calculated as the tangent of the 2D composite curve.
So first of all, the distance along measurements. On the distance along measurements, we go to gradient curve, and here we see the part that says that the parameterization is actually done along 2D. So we're expecting in the measurements along gradient curve, we are expecting measurements along the base curve. That's what this was added at the end of the deployment project because we didn't really test with 3D measurements, so this was taken. But on the other hand, we have the point by distance expression documentation. Where okay, let's actually go to access to placement linear because this one is just for offsets, and these offsets are just the default values that we take if there are offsets present for point by distance expression, which is lateral is to the left of the basis curve facing in the positive parametric direction. So in the sense of the curve where the parameters are rising. This is a very ambiguous thing, of course, but point by distance expression was supposed to be added to make it very similar to distance expression in ISO 19148. Otherwise, we should have been modeling this in the IFC way, but politics. And this is all based on the XY, on the global XY plane of the curve. So if you're measuring to the left, you're facing you face yourself in the direction of the rising parameters, and then the global XY plane tells you if you're standing on the global XY plane and tells you which way vertical, longitudinal, and lateral. Okay, longitudinal not, but vertical and lateral are. But then let's go to the access to placement linear, which on the other hand has no connection to the offsets. This one is this one is based completely on its own definition, where if axis is set, it's the it's the direction of the local z-axis. And if it's not set, it's just a second. Okay, that was something that we didn't add in the end, but it really makes sense. This was something that we discussed in the implementer forum when Peter Bonsma was still leading it. We said that if axis is not set, it takes the global z direction by default. No, it takes the z direction orthogonal to the tangent of the curve, which is in the global z plane of the curve. So you don't have to set it when you're extruding a long section solid horizontal. And for ref direction, if omitted, it's also sort of the same thing. It should point in the direction of the tangent at the point, but of course this should be on 3D because it doesn't really differentiate between the base curve of the point by distance expression or whether it's 2D or 3D. So this one doesn't take into account the distance measurement. This is completely based on the actual 3D representation, the definition here. So you are taking, for default ref direction, you are taking the tangent.
So the tangent of the 3D curve, not the 2D projection.
Yes.
Okay. I will have to change my implementation again.
We are trying to make this clearer in IfcTunnel because, like I said, this was introduced. This part that we're measuring only along 2D was introduced at the end because we didn't have the IFC gradient function. We didn't have the clear way of attaching geometry to alignment, and there were certain conflicting interests which made it impossible to find a consensus in a week, or even less at the time. So we just added that to the documentation. But we will be merging this part as soon as possible, where we now looked into actually encoding the valid representations of the alignment, and this function says that if you have one representation, you can be a composite curve, offset curve by distance, polyline, gradient curve. Actually, there's two parts to this. What happened here? I have an NDiff. Okay. So if you have a curve 3D, if you have a curve 2D, you can have a composite curve, offset curve by distance, or polyline. If a curve 3D and one representation, you can have a gradient curve, offset curve by distance, and so on. Not so important, but the more important part is if we have two representations, then we expect one to be a gradient curve and the other to be the composite curve of the base curve of gradient curve, meaning that we have an object reference check that the gradient curve, base curve, is the composite curve, and that the two representations are linked. So in the end, when you would be measuring along the alignment, you would be measuring either along the composite curve or the gradient curve. So once we have this set up, we can say that the gradient curve is an actual 3D measurement, but it allows us with point by distance expression to measure also along the 2D representation, which is a requirement from the business part. That they have many measurements in 2D, but now I mean most of the measurements they have in 2D, but now we will be able to have the same alignment used as a positioning element and measure along the 2D and the 3D curve here. So this should probably resolve most of these issues, and yeah, then we just have to have a proper documentation on access to placement. I still think we should use the 3D curve for tangents because it's just a weird way of how the domain does these measurements and calculations. They typically measure distance along 2D, but then they take the 3D point with the profile of the alignment. So pretty much the height plus a 2D measurement, and that's what they take as a basis for all positioning. So that's what we're dealing with here. It's a bit of a.
So here, if there, I don't know if there are two representations, so it means that you have one. I think that there is such a discussion regarding the shape representations of the IFC alignment on the implementers forum, but it hasn't.
Yeah, they read it here,
but it hasn't. So this is what you mean, two representations that, for example, the horizontal will have a shape representation attached to it, the 2D shape representation, and the, I don't know, the vertical alignment or the alignment itself would have the
No. The alignment itself would have two representations because the alignment is the only positioning element in this alignment breakdown. The alignment is what can be used for positioning, but how we measure to get to the position can be done along the geometry of the alignment. So the geometry of the alignment would have two representations.
And the measurements will be possible. For example, also the distance along will be measured along the 2D still, or sometimes along the 3D also, or
you would have something like this. You would have IFC alignment, and you would have, let's say, a product definition shape. Let's just go for this. All others are null, or all other all other attributes. So we go just for and 2 is our and 3 is our and we have different items here. So we have, let's say, number 4 and actually let's do this here, as a matter of fact.
so there will be two items.
There will be two shape representations. And we will have number 5, which is our gradient curve. Which has some sort of a geometry. And the first one would be curve 3D type. And number 5. This one would be curve 2D type. And let's say number 6. So number 6 is our IFC composite curve, which is the base curve of gradient. So let's give it 6 here. And then if you're measuring, let's say I have whatever IFC product. I'm just gonna name it IFC product for the sake of it. We all know that this is not possible in IFC, but IFC product that has a linear placement which has an axis to placement linear, which has a point by distance expression. So this point by distance expression has a base curve, of course, and it can be either number 5 or number 6. So let's do number 5 first. Or number 6. And this product can be then positioned on the alignment, for example, or on another positioning element. So let's say product 7 and alignment 1. And it can be either on one or the other. Of course, you wouldn't have two because it's impossible to have two placements, but the linear placement can have an axis to placement linear, which has a point by distance expression measured along 5 or 6. So you can place basically on 2D or 3D. So let's say I have another product. Just going to copy this. Let's say I have another product. Which is, again, this time let's have a linear placement 14. So it's placed on 14. And 14 has this other point by distance expression, so 11. And row positions now is again on the alignment. Let's change this first. And the product that it positions is 13. So now you have a clear way of finding your point, first of all. But of course, the calculation of the tangent, in my view at least, should be done on the 3D always, because that's sort of what the business side expects. Or at least I haven't heard a requirement that the directions or offsets would be done on 2D.
Mm-hmm. Okay.
Offsets. Yeah,
But currently, the point by distance expression, distance along, is measured along the 2D, right?
Yes.
Mm-hmm.
And that's why we are introducing the function that's going to check that if you have a 2D representation and you want to have in one data set, and you have in one data set both measurements along 2D and 3D, then you need to have the curve 2D and curve 3D representations so that it's explicit along which one you're measuring for a particular product, because you might have sleepers. Sleepers are typically 3D, and I think catenary poles are also typically 3D, but you might have something like a box, maintenance box somewhere, and that one would be 2D. So then with the catenary poles, you would be referencing this one, this shape representation of the alignment. So actually the curve from this shape representation, the 5, and for a maintenance box, you would be referencing the 6 with linear placement. Let's say this is a product.
I think I get it now. So yeah, thank you very much.
We're welcome.
Thank you, Sergey, for a very detailed explanation, and hopefully you're going to fill in the rest of the attributes, and we have another example file.
Sergey, in line 14, your reference to hash 9, but that should be maybe 15. Is that correct? Or?
Indeed, that should be 15. Yeah, exactly. So you just have a different way of getting to the back to the alignment. Because the positioning should be done on alignment, because alignment is a positioning element, and the measurements should be done with point by distance expression, and these can be either on 2D or on 3D. Just makes it explicit if we encode this as such, and that's why we introduced the rule, and that's why we also wrote the test instruction to have this instance equality on gradient curve and composite curve to be that the gradient curve points to the composite curve. So this is done in here. We have the gradient base curve, has to be the curve 2D that we query from the alignment representations. So the curve 2D is the composite curve of the 2D representation. This query is already above. This is here. This query is done. Okay, the queries are all here. Sorry. So this query was done on here. You get the alignment representation of the curve 2D, and the curve 2D is on the alignment representation items. The item that is the composite curve. Otherwise, it's false. So you shouldn't be, you shouldn't have other representations here if you have this concept.
Okay, thanks again, Sergey. Shall we try to see whether Adam has a question either on that matter or anything else? Or Anu, do you have any questions on 2.3 concepts?
No. By the way, is there any tool or viewer which is able to support IFC 4x4? No.
Nope.
Um,
We're just implementing it.
Implementing
Okay,
it, yes.
good.
Katenda is working on it. And who else is working on our friends at ESRI as well?
Akka,
And Akka,
ODA
yeah.
probably also, because they have a build.
That's part of the program, indeed, that they can read what others produce. Adam, on your part, any questions?
Really just working through all the Sprint 2.3 stuff. I was just having a look at the example file from earlier, and it looks like should there be over 1 million voxels? Because I would have thought that you would get the product of the number of X, number of Y, number of Z, but it looks like there's about 1 million.
So Lars produced that file and he's not present, so I can neither deny nor confirm your statement there. But we can. You need the information as a sort of a verification of what you've read, or
Yeah.
I would encourage you to do a review of the pull request and say, hey, I get this many voxels. Is this something that you expected? But I really don't know. And try and load the file again and see what it says. But it is quite a huge file, yeah. I mean, at least the voxel. So do you mean, I think all of them are true, right? All of them are filled. Nothing is false here. I'm not sure, because you can also say that some are missing, so to say. Seems like that. Shouldn't there be like 100,000, 104,500?
Would have thought so, yeah, but there seems to be over 1 million, so it seems like it's out by a factor of 100.
Okay, so too many T's are in there, right? As I said, I encourage you to do a review as well. You're all allowed to review also our files, so please do so. So if I understand it correctly, the array of the data is far too big, an order of magnitude too big, so to say.
Yep.
Yeah. Oh, perhaps Lars did a for loop to 10 times too many. We can ask him. I think he's going to be present at the evening session today, so I'll convey that question.
Indeed.
Yeah.
Do we want to have a look at the file that was submitted by Eva from Beaver for 2.3? Have you looked at it?
I've only seen it being posted, and he already found let's say not necessarily a mistake in the checker, but the checker wasn't checking enough. So
right,
he posted an issue, and I need to update the checker. But other than that, the file seemed okay. Is Eva with us? I'm not sure. I haven't been.
No, I don't think so.
Okay.
So that could be a source of inspiration for anyone else.
Yes, as well, correct.
Good. Anything else we wanted to convey to the team? Nope. No other questions? Jan Erik, last chance.
No, I think I had my questions this time. It will be more for sure. Very helpful again, as always.
I'm really happy that you're also opening issues, Jan Erik. It really makes this, let's say, I mean, this time it wasn't asynchronous communication. We talked right now, but it really also gives us time to prepare a good answer.
Yeah.
Very easy to make issues. So, thank you.
Thank you. Thank you. Thanks.
Talk to everyone next week.
Thank you, everyone.
See you next week. Thank you.
Nadia, I will
Australia.
still answer your email.
Bye-bye.
Just on it.
Thank you. Bye-bye.
Bye, everyone.
Of course, to do some marketing, you can also get the toolkit from the hard code, which is also being produced directly from every commit and is being used in the checker, of course.
That's great. One question that I had, and this is just maybe coming from a little bit of ignorance on my end, is do any of you happen to know if there is a concentrated listing of the entities or the new components associated with Addendum 1? You know, that's all kind of in one location, or
that's your change log typically that you get in the documentation.
Okay. Awesome.
Yes.
Okay, because that's going to help me to try to build momentum and see what, you know, the team can look into, that kind of thing. So basically, if it's in Addendum 1, that's going to give me a good shot at building excitement and alignment to go ahead and start looking into those types of entities. And like I said, Sprint 1.2 is pretty great. There's a lot of great georeferencing content that is of interest on the consumption side. So okay, so I'll go look at the change log and get that collated list, and then see what lines up with the IfcTunnel project, and that's could give us like a good footing. So awesome.
Addendum 1 is the quote quote 4.3 ongoing improved version, right? That is clear to you, right? And we build on top of this. So we think so that we make sure that this one basis, even though this is moving ground, is the basis upon which we populate the 4.4 extension. And we inject as well recommendations and clarifications and specifications into this Addendum 1, because we've gone through some of those concepts that needed to be quote quote polished.
Yep.
Yeah, so be careful if you're looking at Addendum 1. There's no tunnel specific concepts or voxels or anything like that in it.
I know.
Nope.
No.
Okay. But you'll have that in the delta that you'll find on the GitHub through the GitHub via the HTML documentation that says what 4.4 adds to Addendum 1, or actually to 4.3, but it's more or less.
Okay. So
okay, but good news. Thank you very much.
Yes.
For you know, driving this into a such a big company as the SRI. I know this isn't that easy to plug oneself into the release process. So good, congratulations on that, of course.
Yeah, thank you. Hopefully it's not beginner's luck. So,
maybe.
So right.
But capitalize on it.
Yeah. So that's all I had, and thank you as always. So,
thanks to you, lovely. Eric and Klaus maybe should give you the floor. What questions you might have?
I don't have any questions right now.
Neither do I.
Okay. So maybe what we could do then briefly is, as we did this morning, maybe lead you to the example file that we have for 2.3, since I don't believe it's merged yet, right? So we need to maybe just give the indication as to where this file is. And we could go through as well the file that Beaver Control has submitted, given it passed, if I'm not mistaken, it passed the checker. Do you want to do this, Lars?
Yeah, I can do that. I wasn't in this morning, so I'm not entirely sure what you discussed, but
well, actually, to tell you the truth, this morning we discussed more around. Well, we discussed two things actually. One was the voxel geometry, which we took people through again, so through the documentation, so that they understand how this is organized, and the rest of the discussion was more on alignments.
okay.
But then
Yeah,
we still covered. Yes, please.
And someone, I talked to Stefan, and someone actually discovered there were errors in my voxel grid in the example file, but hopefully I've fixed that now.
But you did that error on purpose, just to see whether people checked
yes,
what you did.
Yes, of
Exactly.
course. Always.
Always.
Yeah, all right. So just to point to, first of all, then the example files. So in the tunnel deployment repository, since neither the example file for 2.3 or 2.2 has been merged, and we can talk about why also, it's still in pull requests. So you have a IfcTunnel Dep 2.3 and 2.2, and those are my files. So you can just fetch the pull request if you want to have a look at the file, but at least it now it passes the checks and so on. So, and it should contain everything up to sprint 2.3, including alignments and classifications and voxel grids. So that's that. And then you said Beaver Control as well.
Mm-hmm.
This one.
Mm-hmm.
Yes. So this actually, I think it passed the checks, but and I just saw this as well. There is still a little bit of an error, where we should actually add a where rule to the voxel grid, because if you look at the voxel grid here, you have the size of the voxels in X direction, Y direction, and Z direction, and then you have the number of voxels in each direction. And in this case, it's 1 in X, 1 in Y, 1 in Z. So that means that there is actually only one voxel, which means that this list here should have only one value.
Indeed.
Yeah. So yeah, I don't know what else you want to have a look at. I haven't had the opportunity to check this file in detail. I've actually been going through the files from Tekla Trimble again.
Did they provide something with a voxel, or because last I think that Artemis had deleted her submission?
Tekla Trimble.
The Tekla team. Okay.
Yeah.
Hannu, yeah.
Hannu, he has provided files up until 2.3 as well.
Okay.
Yes.
I'll check it. Okay.
But he actually has everything so far in one single pull request. So it's a little bit of a work to go through. So you see there is actually 8 files in here. With yeah. But he has up until 2.3 as well.
Okay, good. I haven't seen this. Okay, good. Thanks.
Yeah. So yeah, I don't know.
Sergey, would you mind maybe just for maybe Michael's attention, Michael's interest, go through the documentation on voxel?
Certainly. Share my screen.
Since we touched the subject.
Go to the voxel. Good. This is what we're testing. So our voxel grid is an index-based data structure. It pretty much just holds one array of booleans that represent our predefined voxels, which are defined in the same data structure. What this means is that we first define the voxel size. Each voxel grid is made up of the same voxels. This is 3 length, non-negative length measures. So let's say our voxels are 10 by 10 by 10 centimeters. In that case, our voxel size X has to be set. Voxel size Y and Z are then taken from the value in X. So these two are optional. This cardinality with a question mark here means that these are optional. And as you see, the value from voxel size X shall be taken if not given. So that's the first thing. Now we have the size of the voxel. Now we have to define the size of the grid. And with the size of the grid, again, we have 3 entries, which are integers. It was a good point from Stefan this morning that it might be feasible to have them as positive integers, since we're not going to have a negative grid size. Which could be an option, but let's test this with positive integers first. So now we have a number of voxels in the X direction, Y direction, and Z direction, which are whole numbers. And again, the same logic applies. If not given, the value from voxel X is taken. So if you have 1,000 voxels in the X direction and you want to have the same number of voxels in Y and Z, this is the only attribute that has to be populated. So now comes the final thing, which is the actual voxels. Since we have a grid, let's say 1,000 by 1,000 by 1,000, now we populate the grid with booleans. And that means that each compartment along X gets its value. So this list can get quite long, of course, which is something that we have to test if we can actually produce arrays that long that will hold this much data. But the principle is that we go first along X, then Y, and finally Z. So you're placing your voxels along X with just true, 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 false, true, and that way you're populating the grid with actual voxels. Then you go by X, and then finally by Z. So you're populating the first level first, or let's say the first X axis first, then the second X axis third, so on, until you populate the entire area of the first level. You go to the second level and you do the same all over. This is how it's encoded. And the initial coordinate system is defined by the local placement of the product that has this voxel geometric representation. Each placement has 3 axes, and those are the initial X, Y, and Z axes.
Klaus, you had a question?
Yeah, exactly.
Me. Is there a kind of reference point? Where do you, when you place it, is there an origin implicit?
Of course, that's the object placement of our product. You know, this is the, if we go to our product, this is the way geometry works. So let's say we have our product, which has 2 attributes, a placement and a representation. This object placement defines both the insertion point and the initial coordinate system.
Yeah, but is it voxel 0, 0, 0 that ends up at the insertion point?
Precisely, yeah. That's
okay, but then negative integers could actually place. You have 8 choices in 3D if you allow negative sizes for X, Y, and Z.
Completely agree. That's why I had a slight epiphany when I said that it might be a good idea to restrict them to positive integers. But you're completely right. It might be a good idea to allow this, nevertheless, if you want to position also. If the 0, 0, 0 is the origin, you might want to position in other directions also.
It might be a very easy trick to do mirroring about planes, the 3 planes.
Of course.
Otherwise, you have to rearrange all the voxels to make a mirror image. Okay, that was one thing. And then why is each voxel represented by a Boolean, just a bit, and not allowing for a color or something?
That's a great question. that's the other concept that we're looking at, which is voxel data. So if we're just looking at, basic representation of geometry, we're just populating space with those voxels. But then we introduce this voxel data concept. Let's go to here, which allows us to put integers, labels, logical, real or vector on each voxel. It uses the same mechanism, so it's connected by index. So each voxel, again, can get its own vector, its own real value, logical value, label, or integer. For colors, we were looking at the tessellation principle, which also by index attaches colors. But that one's a bit more, that one's quite a weird one, I guess, because it's only allowed for tessellations. And I guess we have to look into reusing it somehow. But in principle, this voxel data concept attaches to voxels other values. So the voxel grid itself is very efficient in its data structure.
From my end, I just had 2 questions, and they might be kind of silly, but I guess that's okay. Back to the actual the voxel grid documentation page, the 7th attribute, the voxels. So is the idea it's just all of that information, all of the attribute information that goes on a single line? Is that correct, or is it? No.
Correct. It's just true, false, a million times.
Right. Okay. And there aren't any, and again, like this is coming maybe from some ignorance on it. There aren't any anticipated issues there if you get a very large, voxel grid.
We do have some concerns there, of course, with very large voxel grids, but we don't have much experience with how large these things can get. So we might have to consider something there. But you know, 1,000,000 bits is still not that big of a deal to deal with. But if it goes further and further, it might produce some problems, of course, at some point.
Awesome. Oh, that's great, and gives me a kind of lead I can ask on my end and do some digging there. The second question I had was,
thanks. That would be great to get some feedback on that.
Okay. Now I'm obligated.
Yes, indeed.
No, but I am curious to ask about that on my end. The second question I had is, do any of you happen to be familiar with NetCDF at all, or is that new to everyone, or?
Completely new to me.
Okay, so that's might be another one, a homework assignment on my end, because my understanding is like on the Esri side, it looks like when we're working with voxel data, it is tied to like a NetCDF format. So we, as part of our interoperability, we need to figure out how, like, on the consumption of the IFC side, we get it expressed in whatever conventions are required by NetCDF. But if nobody on the call knows about it, no worries.
Can you provide us some links to the documentation about this format, if there's something publicly available?
Yeah, I'll shoot it in the chat. Awesome. That's. I shot a link in the chat there. So, okay, thanks very much. That was very helpful.
I think you're the helpful one this time.
Oh, hey, I'll take it.
Thank you very much. If you can get us some feedback on that, then NetCDF, definitely we will look into this.
Okay. Well, and hopefully it's just a matter of that the attribute listings coming from, like, the voxel grid, for example, there isn't any big fundamental missing attribute that we needed to get it expressed in terms of NetCDF on our end. So
I think we made Michael, we made an initial assessment of the amount of data that would relate to a voxel covering a tunnel of 2 to 3 kilometers of something like this. If the idea were to have one voxel, one unitary voxel to cover everything, whereas we believe that there might be as well this approach of sectioning the tunnel in different voxels and different voxels with different level of granularity, some being more detailed and others being less detailed, and the size of the box changes accordingly. So, and if I recall correctly, that didn't lead us to believe we might run into major problem, but still we need to get our hands on some real project voxel data to of course challenge the concept.
We got a couple of files in proprietary, I would assume proprietary formats from our geotech team, which felt actually a little bit more voluminous, or whatever you call it, in actually, but I mean ordinary text formats.
Yep.
So I think we covered those, but it's good to check this, I think.
Yep.
Yeah, I don't know that I could get a hold of any. Oh, sorry. I don't know that I could get a hold of any data sets on my end. I can't make any promises there, but I am awful curious about the size that maybe we would see. So.
Yep, please. Good.
The file format itself in IFC is actually quite efficient in data. I mean, it's not as efficient as HDF5, of course, for numbers, but it is quite efficient because each and every one of its characters is ASCII encoded, meaning that it's 1 byte. So with numbers, with big numbers, you actually have some loss of data, but and for example, with especially with booleans, you have a lot of loss. So HDF5 here, if they are using the same data structure with booleans, might produce much smaller data sets. So this would be an interesting exercise, maybe to look at this and not even use IFC for voxels all the time. I mean, just for, you know, certain semantic information, conveying certain semantic information, and maybe some clash detection, but the rest, you know, voxels we could do in HDF5. That what I'm trying to say is our Boolean takes 3 bytes in an IFC, and theirs takes probably 1 bit. So we're a bit over the top.
It's the dot T dot.
Yes.
Yeah.
Precisely.
If I may, back on the suggestion that Klaus was making earlier on, are we sort of stepping back and allowing for negative integer?
No, we have voxel data.
Sorry?
We have voxel data for that.
Okay.
Voxel data is for the other information.
Yeah, but I think, Michel, you meant this
yeah, I know what.
Yeah.
I know. Yeah. You meant the positive integer, right?
Yes.
Yes. Yes.
Yeah, we might reconsider that. Klaus had a good point, of course.
Okay.
Only that it shouldn't allow for 0, probably.
Yeah, non-negative. Non-negative.
Yeah, I mean, if you
non-negative is definitely not the solution.
Yeah, non-negative, then you're safe. If you allow a general integer, then someone might try to put a 0 there, which would give nothing out.
We don't have a non-negative integer anyway.
Okay.
But still, we need a 000 voxel anyway, so.
Okay, so food for thought. We still need to make up our mind on this.
Yeah, and there's one thing that I just remembered. 0 is definitely not an option in Express, because the index starts with 1 in Express, not 0.
So for all of you, just try to summarize the discussion about exactly this in an issue that's in the chat, and you're more than welcome to partake and cast your vote, so to say. There are 2 options mentioned, and also 2 different problems that have popped during both of the sessions today.
Good. Thanks. Okay. So we've answered Klaus' questions, Michael's questions. You said you had nothing. If we don't have anything else to elaborate upon, then I would simply suggest we adjourn this call. We have another one. We have 2 other ones on following week, next Thursday. Anyway, are we good?
Thank you once more.
Yep.
Thanks
Thank
to
you.
you all. Thanks for your
Thank you.
commitment. Thank you. Thank you.
Thank you.
Bye bye.
Thank you, everyone. Have a nice evening and or
You
day.
too.
You too.
Bye.
Cheers.